Welcome to Spring LIB.
Let us imagine we have a rod ACB which is hinged at point C, and this distance is 1.2 inches between A and C, and between C and B we have 0.9 inches. And let us say that we have two circles going around points B and point C in such a way that around B we have a circle. Sorry, my pen slipped a little bit here. Okay, so yeah, and then around point A we have a circle. So they are hinged at point A and B. The radius of circle at point P is 1.5 inches, and the radius of circle at point A is 0.6 inches. And this whole setup is making a motion along a fixed wall which is circular, and the distance of that wall from point C is going to be sum of 0.9 and 0.15, the radius of this guy and this distance. So this distance at the point of contact is 2.4 inches. So let's say the rod ACB is rotating counterclockwise with an angular velocity of 40 radians per second. Then what are the angular velocities of disk A and disk B? Okay, so like in all programs, we break the motion into translation and rotation, and we take that at point of contact. So this is not a gear problem, this is a rolling problem. So in rolling problems, basically the point of contact has velocity 0, net velocity 0. And this is in a sense similar to the gear problems, because if the surface is fixed and you are rolling without slipping, then at the point of contact the net velocity has to be 0. So point of contact has net velocity 0. These are the two facts we will use. They just simply come from the rolling motion part. So let us try to solve this problem. So what is the translational velocity? So let's look at disk B first. So for disk B, what is the translational velocity? So this is B translational velocity. So that translational velocity is going to come from the arm ACB. So this is moving counterclockwise, so the center is going to move up with some velocity Vt. And for a rigid body, this is going to be same at all points. So at the point of contact, let's call this point of contact P, the velocity is also going to be Vt for translation. This is the translational part. And then there will be a rotational part if this is rolling, and this rotational part has to cancel out this Vt because point of contact has net velocity 0. So then omega has to point out like this, omega b, and at the point of contact this should be omega b times radius of p. So since net velocity is 0 at point P, so since Vp is 0, we have this the net velocity Vt equals omega b Rb. And what is Vt? Vt is going to come from the omega of the rod times, let's call it RCB, the distance. So this will be 40 radians per second times CB is 0.9 inches. These are all in inches, equals omega B, we don't know, and then RT, sorry, R of B. So the radius at B is 1.5 inches, so 1.5 inches. So 3 can cancel both of them. So 3 5s are 15, 3 3s are 9, and then inches get cancelled. So basically omega B is going to be 120 radians per second. Okay, now let's look at point A. So at point A, sorry, let's look at circle A. So this is circle A. Now this also has a translational velocity. So this is the translational part for A. Now this translational velocity is going to come from the motion of AC. So this will be Vt, and then this is the point of contact. So this will also have velocity Vt. Now the rotational part here is again our circle A, and to have net velocity 0, now this radial velocity, because of omega, now omega has to point like this, so that our radial velocity at this point, because radial velocity is omega cross r, it's perpendicular to omega and perpendicular to the radius vector. Radius vector is like this, so it's perpendicular to radius vector, and omega has to be, if you take a right hand, curl your fingers, then omega has to point up so that the cross product actually points in this direction. It's kind of obvious. If your circle is moving like this, then this point is going to go like this. Okay, so omega cross r is just going to be omega a ra. And again, since at point of contact the net velocity is 0, Vt is going to be Pr. So this will become Vt is going to be omega times Rac, the distance between A and C, and Vr is going to be omega A, which we don't know, and then radius of A, which is 0.6 inches. And we know that omega is 40 radians per second. Rac is 1.2 inches. Omega A times 0.6 inches. Inches cancel, 0.6 cancels 1.2 two times. Then omega A is going to be 80 radians per second. So again, using the principle of separation of velocity into translational and rotational part, and for rolling without slipping, applying the condition that velocity at point of contact Vp is 0, we can get the required quantities omega A and omega B. See you in the next problem. Bye.